Welcome to the explainer. You know that moment, the one every Python user hits, where your code, which is full of loops, just gets too slow. Well, today we're going to show you how to smash right through that wall with a tool called NumPy. So let's start with a problem I'm sure you've been there. You've got thousands, maybe millions of numbers you need to work with. But when you try using standard Python lists and loops, your code just grinds to a halt. It really feels like you're stuck in the world's worst traffic jam. So what does this traffic jam actually look like in code? Well, let's take a look at the classic old-school way of adding numbers from two lists together. The traditional way, right, is a for loop. And sure, it works, but it's like having a million cars trying to get through a single toll booth. It processes just one item at a time. Now, if you scale this up to a million data points, this one-by-one approach becomes a huge bottleneck. It's just painfully slow. But what if we could just blow past that traffic jam? What if we could build a brand new multi-lane superhighway for our numbers and process all of them at the exact same time? Well, that is exactly what NumPy does. The very first step on the superhighway is always the same. You got to import the NumPy library. And by convention, pretty much everyone in the data science world gives it the short nickname NP. You are going to see this everywhere. So instead of regular old Python lists, NumPy has its own supercharged data structure called an array. We can make them really easily from a list we already have, or we can use these handy built-in functions to just whip up an array of all zeros, or all ones, or even a sequence of numbers, kind of like Python's range function.
Okay, buckle up, because what you're about to see, this is the real magic of NumPy. This is the core idea that changes absolutely everything.
Just look at the difference here. It's night and day. On the left, you've got the slow, clunky Python loop, chugging along one step at a time like a tortoise. And on the right, that's the NumPy way. It's a rocket. We just convert our lists to NumPy arrays and add them with a plus sign. That's it. This incredible idea of replacing a loop with a single operation on the whole array, that's called vectorization. So here's the crucial thing to get. Vectorization is just applying an operation, like addition, to the entire array all at once. Behind the scenes, NumPy is running highly optimized code written in languages like C that can do these calculations in parallel, completely sidestepping the slowness of a Python loop. And this isn't just about writing cleaner code. We are talking about raw, unadulterated speed. With large data sets, a vectorized operation in NumPy can be 10, 50, even over 100 times faster than a Python loop. It is a total game changer. All right, so we know it's fast, we know it's powerful, but how do we actually get the specific bits of data we want out of these arrays? Let's check out the toolkit. I want you to just think of this like a spreadsheet. Here, we've made an array with numbers from 0 to 11, and we've just shaped it into a grid with 3 rows and 4 columns. NumPy makes it super easy to pinpoint anything in this grid. And getting data out is so intuitive. You want a single cell? No problem. A whole row? Easy. And check this out. That little colon acts like a wildcard. It basically says, give me everything from that row or column. It's a simple and really powerful way to slice and dice your data. Okay, but hang on. Here's a super important detail, a classic gotcha that every new NumPy user needs to learn. When you slice an array like we just did, you're usually not making a brand new copy of the data. You're creating something called a view. So watch this example closely. We start with our array A. Then we create a little slice of it and call it B. Now let's change the first element of our slice B to 99. But, whoa, look what happened to our original array A. It changed too. That's because the slice B is just a view. It's looking at the exact same data in memory as A. This is done for performance, but man, it can really catch you by surprise. So what do you do if you actually need a separate, independent copy that won't mess with the original? Well, you have to explicitly tell NumPy, hey, make me a real copy. You do that by just adding .copy to the end. All right, let's put all this together. Let's solve a real problem without writing a single for loop. This is where we really start to think in arrays. So our goal is pretty simple. We've got an array of numbers, and we just want to filter it, keeping only the values that are greater than 1. Here's our starting array, nice and simple, just a mix of positive numbers, a -1, and a 0. Now here comes that vectorization magic again. Instead of a loop, we can just ask NumPy a direct question, almost like we'd say it out loud, which elements in A are greater than 1? And we just write A greater than 1. And check out what NumPy gives us back. It's not the numbers, it's a new array, the exact same size, but filled with true and false values. It's true wherever our condition was met. This is what we call a Boolean mask. Think of it like a stencil that shows us exactly what we want to keep. And now for the final, really elegant step. We can use that mask as a filter. We literally just put the mask inside the square brackets of our original array. We're telling NumPy, hey, just give me the elements from A where this mask is true. And bam, just like that, 2 simple, readable lines of code, 0 loops, and we have our filtered data. This is what it means to think in arrays. You stop thinking about one element at a time and start thinking about your whole data set at once. So, we've covered a lot of ground here, right? We've gone from being stuck in the slow lane of Python loops to flying down the NumPy superhighway. Let's just quickly recap the key things to take away. So remember these core ideas. It all starts with NumPy's fast arrays. The secret sauce is vectorization. That's how you ditch those slow loops. Remember that operations like a plus b just work on the whole array at once. Oh, and the big one? Slicing creates views, not copies. If you need a totally separate thing, you have to use .copy. And finally, make friends with those Boolean masks. They're your best tool for filtering data efficiently. You now have the keys to the engine that powers pretty much all of data science in Python. So the only question left is, what slow, clunky loop in your code are you gonna replace first?